Saxon Algebra 1. Ooh, the S didn't come out. Saxon Algebra 1. Lesson 24. Last time we talked about the fact that if you have an equation, you can add the same thing to both sides and it will be exactly the same. This time, spoilers, as you already know, if you have an equation, you can multiply both sides by the same thing and get another equivalent equation, right? Let me put some numbers in there so you can see how that works. 24.1, right? This is our puffy cloud of knowledge. I remember learning these things when I was, I think in grade school. I saw them for the first time. You've probably seen them before too. But the things with the letters, and I used to sit there and study them going, I don't get how this is math. Like, that's so obvious. I don't understand how it's math. So if you have that feeling a little bit, I understand. 5x equals 20. Okay, our strategy is exactly the same. We see it's an equation. We look for the letter. We know our goal is to get the letter by itself, all right? That's so important. I know that's obvious, and I keep saying it, but at the beginning of a problem, the biggest challenge is always, what am I supposed to be doing here? And so I want to just train that process into your brain that once you notice it's an equation, you look for the letter and go, okay, I want him by himself. What's happening to him? He's being multiplied by a 5. Oh, the opposite of multiplying is dividing. So I'm going to divide both sides by 5. Now, just like the additive property of equality also works for subtraction, same for the multiplicative property. I made it into one word, the multiplicity. This works for division as well. So as we're dividing, this process rules over our calculation and makes everything okay. And then we divide that and we get x equals 4. That's the right answer. And we can again say that these two are equivalent equations. They have the same value, right? They have a different shape, but the same value. And that's the thing about algebra is if you're doing it right, you're creating a series of equivalent equations. I forgot the U there. Okay, now, let me flip to a fresh page. Let's deal with an ugly little issue that often raises its head in problems like this. What if we're multiplying by a fraction? Okay, well, the multiplicative property of equality says that if we're multiplying something, we divide by it to make it go away. But look what happens. Ew, dividing by fractions? Is disgusting. We do not want to do that, okay? No, there's gotta be a better way, and there is. We do not have to do this. What we do instead, I'm just gonna rewrite the problem so you can see it with fresh eyes. What we do when we have a fraction that we're multiplying by and we want to make it go away, we don't divide, multiply by the reciprocal. This saves us the drama of having to divide by a fraction, okay? So whenever you see something like this or that, and your first thought is, oh, I need to divide to make that multiplication go away, but then you see that you're gonna create a horrifying mess, that's when your brain kicks in and goes, oh, there's gotta be a better way, and there is. Instead, I wanna multiply by the reciprocal of this. And a lot of times, if you have a whole number on the other side, A lot of students like to put that over a 1 so that everything lines up. I think that's a great idea. Now, what's happening over here is that when we multiply these two together, because we're multiplying by the reciprocal, 5 times 2 is 10. 5 times 2 is 10. 10 over 10 equals 1. And whenever we have 1 in front of a number, it just goes away, right? We can ignore it. So where 1 poofs, it disappears, right? So now all of this side is gone, and we just have x equals, and now we multiply here. With multiplying fractions, we go straight across the top, straight across the bottom, 35 over 2, and that's our final answer. You do not need to make that into a mixed number. Improper fractions are I was going to say precious. That's true. Maybe an exaggeration, but they're fine. They're preferred was what I was trying to say. Precious and preferred are not that close. I don't know why I stumbled over that, but I did. I do notice that when I really get in the math mode, sometimes my words fly out the window. So sorry about that. Sorry, students. Okay, last one. I say crazy things, don't I? Sometimes 24.3. This is the last one. 2 1/4 x equals 3. Proximity alarms are going off over that mixed number. I wouldn't even copy it. I would fix it in the book, but let's fix it. Remember, we multiply the bottom times the big plus the top. 4 times 2 is 8 plus 1 is 9. So this is 9 over 4 times x equals 3. I first think, oh, let's divide by that 9 over 4, and then I think, ew, no, I'm multiplying with a fraction, so I'm going to use the reciprocal. Last time, I used parentheses to show it. This time, I'm just using a dot. Either way is fine. And we multiply this side by the same thing. I'll put that over a 1 so that it all lines up. As soon as I see this pattern, I don't have to multiply through and write 36 over 36. As soon as you get your two reciprocals, or your pair of reciprocals lined up, you can just do that. And you're done. And then we do x equals 12 over 9. Now, that looks really good, but I can see that can be reduced. And I can see, oh, I could have canceled up here, couldn't I? That's okay. I missed it, but I'll do it here. 3 goes into both of these numbers. So I'll say x equals 4, 12 divided by 3 over 3. That's our final answer. And just to show you that everything balances out in math world, I'll say, okay, what if we went back here and we remembered to cancel here? I mean, you probably saw it. 3 and 9, I can go 1 and 3, and there's my 4/3 right there, right? 1 and 1, 1 times 4, 1 times 3. I'd get the same answer. Is that all? Oh, there's one more. No, there's 2 more. Are you ready? These are fun. They're pretty flippin' easy, don't you think? Example 24-4. This one is set up a little differently than what we've seen before. X divided by 3 equals 9. Huh, that's different. There's a fraction here, but it's actually, we can think of this as division. Right, we remember that this sign always says divided by. I tend to forget that sometimes, right? The fraction line always says divided by. So that's 8 divided by 3, and that reminds us, oh, just multiply it by 3. I put that in the way. So I'm going to multiply it by 3, and I'm going to multiply this side by 3. Now I'm using parentheses to mean multiplication. I go all over the place just to mix it up. This 3 and this 3 cancel. X equals 27. Okay? It's fairly unusual to have a problem that's formatted like this. I mean, not entirely, but get used to that. Don't let that scare you, okay? And then the next one, which has an A and a B. I'm not sure why John suddenly decided to throw letters in on top of it. but he's going to expand on this idea. In the first one, in part A of this problem, it's x over 2.5 equals 7. X divided by 2.5 equals 7. Okay, well, first of all, 2.5, no. X over 5/2. Notice how I'm exaggerating the line so that I can see clearly which is the bigger fraction and which is the smaller. Equals 7 over 1. I'll do that just so they're both in the fraction club. Now, to make this division by a fraction go away, I can use, I don't have to use the reciprocal. I can just multiply, just like we did here. Take what you're dividing by and multiply it by that. Take what you're dividing by and multiply it by that. So I multiply both fractions by 5 over 2. That cancels. Now notice, not the reciprocal, because we're creating fractions up and down, right? So this becomes 5 over 2 over 5 over 2. That equals 1. That's another way to look at it. But I think of it as here we're dividing by 5/2, here we're multiplying by 5/2. That makes sense to me. That cancels, and I get x equals 35 over 2. That's the right answer. This problem has a part B, so let's just slide that in right here. In this one, it's p over 3/2 equals 4 1/3. All right, don't like that. Gonna fix it. P over 3/2 equals bottom times the big plus the top, 12/13. All right, I turn my attention to this side. There's the P. I want it by itself. It's being divided by 3/2, so I am going to multiply by 3 over 2. And I can make that over 1 if that helps me. These lines are a little crooked, but these are the numerators, these are their denominators. So I can cancel, right? However, I have to do this one by 3 over 2 as well, right, to keep it in balance. And I get P equals, and now we can simplify here, those cancel, 13 over 2. And that's the right answer. Okay, so what we're experimenting with here is how to undo division in a problem, right? That's basically what we're doing. We have division written into the problem, and so we're undoing that division by multiplying. That's ever so slightly different than here, where we were multiplying by a fraction, okay? And then we were setting up a situation where we were gonna have to divide by a fraction. We didn't wanna do that because then we would have to simplify something like this. No. So here, when we're multiplying by a fraction, that's when we use the reciprocal. Because undoing that multiplication creates a mess. We don't wanna create a mess. If John gives us a mess, like this, right? He's giving us a mess, then we fix it. But we don't want to create that if we can help it. Okay, I'm going to stop talking now and say, yay, congratulations, you're done with lesson 24. Goodbye.